1220 tokens per second. That's a 70 billion parameter language model, the same scale as the models powering enterprise AI tools, running locally on a 1099 Mac Mini M4 Pro with 64 GB unified memory. Not a render farm, not a water-cooled GPU tower, a box the size of a paperback book sitting on a desk. I've been running this for a week. It answers questions, reviews code, drafts emails. All of it offline, all of it private, zero API costs. And the setup took me 25 minutes. Here's exactly how it works, what the real numbers look like, and the one decision point that most tutorials get wrong. Before we get into setup, I want to explain why 70B specifically matters, because a lot of people are running 8B models locally and wondering why they're underwhelmed. The jump from 8B to 70B parameters isn't a 9x improvement on a linear scale, it's a qualitative shift. These are the things I've actually seen break on 8B that work reliably on 70B. Multi-step reasoning. Ask an 8B model to debug a function, then refactor it, then write a test. And by step 3, it's confused about what it was doing. The 70B stays on task. It tracks context. It doesn't hallucinate the earlier steps. Complex instruction following. Edge cases, nested conditions. Do X except when Y, unless Z is true. 8B fumbles this constantly. 70B handles it cleanly most of the time. Code quality. I'm not saying 70B is going to replace your senior engineers, but on human evil benchmarks, LLaMA 3.1, 70B. Instruct scores 80.5% versus 72.6% for the 8B, about 8 percentage points. That gap shows up in the real world. First-run compile rates are noticeably better. Writing nuance. 8B models have a tell. They write in that flat, slightly robotic way that anyone who's read AI content can spot immediately. 70B gets close enough to human cadence that it takes more effort to identify. The catch has always been the hardware. A 70B model at full precision, FP16, needs about 140 gigabytes of memory. That ruled out almost every consumer machine until very recently. The M4 Mac Mini with 64 GB unified memory changes the math. Here's what makes Apple Silicon different from a traditional GPU setup. And this is the part that most people gloss over. On a conventional setup, you have two separate memory pools. System RAM for your CPU and OS, VRAM for your GPU. They don't share. An RTX 4090, which is one of the best consumer graphics cards you can buy, has 24 gigabytes of VRAM. You cannot run a 70B model on it. Even a Q4 quantized 70B needs around 40 gigabytes. The hardware just doesn't exist in the consumer GPU space at that memory size, not at anywhere near this price point. Apple's unified memory means the GPU and CPU are drawing from the same pool. All 64 gigabytes are available to the model. There's no data transfer bottleneck between CPU memory and GPU memory. It's all one thing. The M4's GPU cores can access all of it directly. This is why the 64GB M4 Mac Mini is the specific machine I keep recommending, not the 24GB or 32GB configs. Those can't fit the model. The 128GB M4 Max works too, but it costs over $2,000 more, and the speed difference on 70B inference is not dramatic enough to justify it for most workflows. The 64GB M4 Pro configuration is $1,999. That's your target. It's the minimum config that can actually run this model without memory pressure. This is the section most setup guides skip, and it's the most important one. Running a 70B model locally means you're running a quantized version, a compressed representation of the model weights. The question is, which quantization level? Here's what the options actually look like for LLaMA 3.1 70B. Q8 0. 8-bit quantization, about 70 gigabytes. Closest to full precision. Won't fit on a 64GB machine. Doesn't matter how good it is if you can't load it. Q5KM, 5-bit mixed precision, about 55 gigabytes. Technically fits, but you're leaving 9 gigabytes for the OS and everything else. In practice, under sustained load, I've seen memory pressure kick in, which causes slowdowns as the system starts swapping. It's uncomfortable. Q4KM, 4-bit mixed precision, about 43 gigabytes. This is the sweet spot. It fits cleanly, leaves room for your OS and other processes, and the quality loss compared to Q5 is genuinely small on most tasks. On standard benchmarks, the gap between Q4's KM and Q80 is typically under 1 to 3%, though math-heavy and reasoning tasks can show more degradation, so if that's your primary use case, it's worth knowing. Q3 and lower. The model starts degrading noticeably. Reasoning tasks show it first. Don't bother. The trick with Q4KM, when you pull LLaMA 3.1 70B via Ollama, this is what you get by default. Ollama auto-selects Q4KM as the standard 70B download. So if you're using Ollama, you don't have to think about this. It's already made the right call. If you're using MLX directly, you want the MLX Community Meta LLaMA 3.1 70B Instruct 4-bit model from Hugging Face. That's the MLX converted Q4 version. You have two main options for running this locally. I'm going to walk through both, so you can pick the one that matches your workflow. Handschwalt. Path A. Ollama. This is the easier path. Ollama is a runtime that abstracts the model loading, quantization selection, and API server into a clean CLI. That's genuinely it. Ollama starts a local API server on port 11434. It's OpenAI compatible, meaning any tool that points at the OpenAI API can be redirected to your local model by changing one environment variable. That's how I have Continue, my VS Code AI coding extension, pointed at the local 70B. 0 code changes, just a URL swap. Path B. MLX. MLX is Apple's machine learning framework, built specifically for Apple Silicon. For certain workloads, especially generation on M-series chips, it can edge out Ollama on speed because it's using Apple's Metal performance shaders more directly. The download here is also 40 GB, but it goes to your Hugging Face cache. First run takes longer because it initializes the Metal kernels. My honest take, start with Ollama. It's simpler, it has a clean API, and OpenWebUI connects to it in about 30 seconds. Once you're comfortable and you want to squeeze more speed out, experiment with MLX. For most workflows, the difference is not dramatic enough to justify the added complexity up front. Let me show you what the actual numbers look like on my M4 Mac Mini with 64 GB RAM. I ran these over 3 days across different prompt types to get stable averages. Token generation speed, 12 to 20 tokens per second on sustained generation via Ollama with Q4 KHM quantization on the M4 Pro 64 GB. At 15 tokens per second, mid-range of what the hardware delivers, a 500 token response takes about 33 seconds. A 2,000 token code review comes back in a little over 2 minutes. That's usable for real work. Is that fast? Relative to a cloud API, no. GPT-4o generates at 40 or 60 tokens on a good day. But here's the thing, people get wrong about the cost argument for local inference. Cloud API prices have dropped a lot. GPT-4o is £0.01 per 1,000 output tokens right now. If you're generating 500,000 tokens a month, a few hours of active use daily, that's $5. A heavy user burning 2 million tokens a month pays $20. The cost math alone does not justify a $1,999 Mac Mini. I'm not going to pretend it does. The actual reasons to do this are different. First, nothing leaves your machine. The prompts you're sending to debug proprietary code, draft sensitive emails, or prototype unreleased product ideas, none of that hits an API. It never crosses the internet. That matters. Second, no rate limits. Hit it as hard as you want, as fast as you want, for as long as you want. No throttling, no 429s, no queuing. Third, it works offline. On a plane, on a ship, in a data center with restricted outbound traffic. The model doesn't care. Fourth, you own it. No terms of service changes, no API deprecations, no model behavior shifts from a silent update. The version you pull today is the version you run forever if you want. That's the real case. If those things matter to your workflow, 1,999 is a reasonable price for them. RAM usage. During inference, 44 GB active. That leaves 20 GB headroom on a 64 GB machine. Enough for your OS, browser, VS Code, Open Web UI, all running comfortably alongside the model. I haven't hit memory pressure once in a week of daily use. Power draw, approximately 40 to 65 watts at the wall under sustained inference load. That's whole system draw, not just the chip. Apple's M4 Pro chip TDP is around 30 W, but the Mac Mini system total runs higher under real GPU load. Your electricity cost for running this 8 hours a day is still negligible. We're talking under $3 a month at average US rates. Heat and fan noise. The Mac Mini M4's cooling is good. Under sustained 70B inference, the fan spins up, but it's not loud. Nowhere near what a high-end GPU would sound like. Here's where it gets actually useful. Open Web UI is the best front-end for local models. It connects to Ollama out of the box, gives you a ChatGPT-style interface, conversation history, model switching, and multimodal support if you add vision models later. Then navigate to localhost 3000. That's your local AI interface. VS Code. With Continue. Install the Continue extension, go to Settings, add a new model with provider Ollama, model LLaMA 3.1, 70B. You now have a local coding assistant with no token limits and no subscription. LangChain, LLaMA index. Point your base URL at http://local host 11434 v1. It's a drop-in OpenAI replacement. The network trick. If you want to use this from other devices on your network, your laptop hitting the Mac Mini's model, set this environment variable before starting Ollama. Now any device on your local network can hit http://111434. Your laptop, your tablet, your other machines, all hitting the 70B model on the Mini. Here's what I want you to take away from this. A year ago, running a 70B model locally meant building a multi-GPU server or spending $10,000 plus on enterprise hardware. The M4 Pro Mac Mini with 64 GB unified memory changed that. $1,999 gets you a machine that runs 70B scale local inference at 12 to 20 tokens per second, fast enough for real daily workflows. The cost math alone won't get you there. But if you need privacy, no rate limits, and offline capability,